Okay, so yesterday we talked about 2 ways to prove triangles congruent. What were the 2 ways? SSS and SAS. And in the SAS, what did we learn about that angle? It has to be sandwiched in between those 2 congruent sides. Okay, so today we're talking about 2 additional sides, which would be the ASA, or 2 different ways, the ASA and the AAS. Okay, and the ASA is the angle side angle. And it states that if 2 angles in the included side of one triangle are congruent to 2 angles in the included side of another triangle, then the triangles are congruent. Okay, so just like with the SAS and the ASA, the side has to be sandwiched in between those 2 angles. So we have an angle here, and we have an angle here, and this is an included side. Okay? So it has to be angle, the next consecutive side, the next consecutive angle. And sometimes it helps to get your finger and start at one end and work your way around. And it has to be consecutive, okay? So that is angle, side, angle. So here's an example. CP bisects angle BCR and angle BPR. We're trying to prove those 2 triangles congruent. Okay, so it's bisecting 2 different angles. What does it mean to bisect? Cut it into half, which creates 2 equal parts, right? In this case, it's going to be 2 congruent angles, right? All right, so it's bisecting this BCR. What can we get from that? That these 2 right here are going to be congruent, right? And it's also bisecting the opposite angle, and so these 2 we can say congruent, okay? All right, so that's probably all we can get from the given. So then we go to the picture, okay? And what can we get from the picture? Okay, yeah, the middle line, that CP is congruent to itself. So would that be enough information to prove those triangles congruent? Yes, because we have an angle, an included side, and an angle, right, by ASA. All right, so let's write all that down. CP bisects angle BCR and angle BPR. That's given. All right, so from that, we can get what? Angle BCP is congruent to what? BPR? No. Because this is what's being bisected right here. So if I said BC, BCP is going to be congruent to RCP. And then I could go down to the bottom, and then I would say angle BPC is going to be congruent to what? RPC. And what's my reason there?
Angle bisector.
Okay, definition of angle bisector. Okay, so that takes care of 2 angles, right? An angle here and an angle here. And then we said we went to the picture and they share that side. And so we can say that CP is congruent to, how would I say the second one? CP, don't switch that one, okay? And that is the reflexive property. Okay, so that takes care of the third part, which is the side, okay? And so we said that was enough information to state the triangle is congruent. So I'm going to say that triangle BCP is congruent to triangle RCP. And what was my reason again? ASA. ASA, that's right. Now, one thing I want you to notice, I did not state those in the right order, did I? Up here, but that's okay, as long as they're stated. You just need to make sure you look at the picture and that you put the right reason, okay? Because in a proof, sometimes the order of things doesn't matter, and sometimes it does. Like, before I make this last statement, everything else has to be stated. But I could have switched these 2, the third statement, and it wouldn't have mattered, okay? I would still accomplish what I needed to accomplish. Yes?
All you need to do is prove that those 2 angles are congruent.
Well, it needs to be an SSS, an SAS, an ASA.
You know you're doing an ASA.
Then you have, yeah. Right. And order doesn't matter, yeah. Okay, so the last way is the angle side, which is AAS. And it says that if two angles and a non-included side of one triangle are congruent to the corresponding two angles inside of the second triangle, then the two triangles are congruent. Okay, so this one is an angle and a side. So you have an angle here, you have an angle here, and then this is your side, and this time it's non-included. Okay, so angle, side. But still, you start at one end, and it's an angle, the next consecutive angle, the next consecutive side. Okay, and that is AAS. And so that's the fourth way we can prove triangles congruent. All right, so in this problem here, we are trying to prove these two triangles congruent. This triangle BEC and triangle AED. Now we notice that they overlap each other. And so remember I told you the other day that it's sometimes helpful to redraw those just so you can see what's going on. So there's my blue triangle. Here is my red one. Okay, so it's given that angle EAD is congruent to angle EBC. It's also given that AD is congruent to BC. And I want to prove those two triangles congruent. And I need another piece of information. What do you think? Any ideas? Huh? Yes. Okay, they share angle E, don't they? Good. See if they see they share angle E. So I could say that this angle E is congruent to itself by the reflexive property, okay? And so then that would be enough to prove those triangles congruent. What would I use? It's not a side angle. AS, right? Angle, side. Okay? Alright, so we have angle EAD is congruent to angle EBC. And then AD is congruent to BC. That's given to you. Okay? And so really the only other thing we stated was what? Angle E is congruent to itself by the reflexive property. And so then we can say that triangle BEC is congruent to triangle AED. And my reason was angle, side. All right, any questions? Okay, so let's do another one. Now, in this problem, we're told that BR is perpendicular to RS and UT is perpendicular to SU. We talked about one like this yesterday. What can we get from that? Angle R and angle U are right angles. And what did we learn about right angles? They're congruent. There's that theorem that says all right angles are congruent. So there's a congruent pair of angles. We're also told that RS is congruent to US. That's given to me. And we're trying to prove that this side here is congruent to that side. What's going to have to happen? Yes. Okay, I'm going to have some vertical angles here that are congruent. How's that going to help me? Yes. Okay, if I can prove these two triangles here congruent, then I can prove that all the parts are congruent. If I state those angles, those vertical angles congruent, is that going to be enough information to prove the triangles congruent? Yes, by what? Angle, side, angle. And so if I prove those congruent by angle, side, angle, then I can say that these two green parts are congruent by CPCTC. Good. Okay, so let's write all this down. BR is perpendicular to RS. UT is perpendicular to SU. And RS is congruent to US, and that's all given to me. Okay, So then we said from the perpendicular lines, we can say that angle R is a right angle and angle U is a right angle. And what's my reason for that? Definition of perpendicular lines. Okay? And then because those are right angles, we said we could say that they were congruent. And what was the reason for that? All right angles are congruent. Good. Okay, so we've stated a side here. We've stated an angle, and then we notice we have the vertical angles, right? So we want to state those congruent. So if I said angle VSR is congruent to, how would I state the other angle? VSR, it would have to be TSU. Angle TSU, and that's the vertical angles theorem. Okay, so that takes care of my other angle, right? And we said that we were going to use angle side angle. Okay? So that's enough to prove those two triangles congruent. So I now can say triangle VSR is congruent to triangle TSU by ASA. And so now I can prove that VR is congruent to TU by what? CPCTC. CPCTC. All right. Now I want to show you something real quick. I'm going to change this problem up. We're not going to work it all the way out, but I want to show you something. Let's say the problem was changed just a little bit. Okay, and let's say instead of proving those two sides congruent, I wanted to prove these two angles congruent. Okay, I could do everything exactly the same, and my last step, I could use CPCTC to prove the V and the T, angle V and angle T congruent. But what else could I do? You see something else I could do there. If I've stated these two right angles congruent, and I've stated these vertical angles congruent, what could I do, Brendan? I could use the third angles theorem, right? And I could not even worry about proving the triangles congruent. I could go straight to that. Does everybody see that? Okay, so I could use the third angles theorem on that one. Okay. All right. Now, before we do that very last one, I want us just to go back over what the 4 ways to prove the triangle is congruent. What are the 4 ways? Side, side, side. Side, angle, side. Angle, angle, side, and angle, side, angle. So those are our 4 ways, right? Okay. Now, it says that TU and TV measure 3 feet. 3 feet, 3 feet. It says that TY is 1.6 feet. It says that angle U and angle V are 31 degrees. Determine whether triangle TYU is congruent to triangle TYV. So I have these two angles are congruent because they have the same measure, right? I have these two sides congruent because they have the same measure, and they share this one. That's really all I know. Is it side angle side? Okay. So I have this angle here, right? And then it's the next consecutive side, and it's the next consecutive side. Is the angle in between the two sides? Okay, this is our no-no, right? Can't do this because we have angle, side, side. You have to go consecutively. Like if I'm going to do side, angle, side, I would have to do this side, this angle, this side. You see what I'm saying? And it does this angle, this side, and then the next side. Or you go backwards, this side, and that angle. But still, it doesn't work. That's not one of the ways to prove triangles congruent. Okay? So, we would put that no, triangle TYU is not congruent to triangle TYV because SSA does not prove congruence. The angle has to be sandwiched in between those two sides. All right, any questions? Yes, Brennan. Down here? Okay. Okay, so we have another worksheet today. Just a couple of things I want to show you about, kind of like I did yesterday. Okay, so just real quickly, on the front page, what it says 44 down at the bottom, this is like what we did yesterday. You'd have to look at it like number 2 and determine if those two triangles can be congruent. Okay, and so we've got an angle here and an angle here, and then they share this side of them. So can we prove these triangles are congruent? Yes, and so you need to write a congruent statement and put by ASA. Okay, so just kind of like we did yesterday. Then you've got 2 proofs. Okay, this one's a flow proof, and if you want to just do a 2-column proof, I don't have a problem with that. On these 3, you just want to know what additional information you need. If it's something that you can get from the picture, you can just mark it, but if it's what you need in addition to that, it needs to be stated. Okay? On the back page, this is the one where the directions are a little goofy. It says explain how you can use SSS, SAS, ASA, or AAS with CPCTC to prove each statement true. If the triangles are congruent, write a congruent statement and a reason. And that's really what you're going to do, because if I can prove these 2 triangles congruent, then this right here is going to follow suit with CPCTC. Okay? So I need to know, first of all, are these triangles congruent? And are these 2 triangles congruent? Number 1. Are these? Yes, by what? Side angle side. So you would write triangle ADB is congruent to triangle CDB by SAS. And then this right here would follow suit with CPCTC. So really you're just stating the triangle's congruent if they are. Okay? And then the last 2 are proofs. None of these are hard proofs. I have every bit of confidence that you can do these by yourself. Okay? But you can't do them if you don't try them. I'm not going to do 4 proofs tomorrow or at home. For any other ones that you want me to do. So try to do. See if you can do it by yourself. Okay? I bet you'd be surprised that you can do it more than what you think you can. Okay? Alright. You guys can get started. Yes, sir.